Okay. Hi, Professor. Today, our group will be presenting the results of the title, The Multi-Pickup and Delivery Problem with Time Windows, with published in the European Journal of Operational Research in 2018. So, our group member is Resy, Yi, and me. Next. So our table of content is has six sessions. Next, I will be presenting the research background. So let me start with an overview of the problem we are studying. So in our problem setting, its customer request consists of multi-pickup location, but only a single delivery location. So this issue leads to three main characteristics with a multi-pickup, single delivery, time window constraint, and finally, vehicle grounding challenge. Next, these above characteristics are not only academic but also very practical. Now can be seen in many popular applications like number one, cash collection, number two, food delivery service like Uber Eats, Food Panda, and the final one is package consolidation. So these models logistics scenarios share common structure. So the first one on pickup of a request to be complete before deliveries. The second one vehicles must perform on related nodes, including pickup and delivery. The finally, respect for time window as or not. Next. Next is the problem definition. So now look at the formal definitions of the multi-pickup delivery with the time windows. So in this problem, a fleet of vehicle must serve by a set of requests. So its request consists of a multi-pickup location and one delivery node. The second one in time window respecting time window is ignored and finally pickup must occur before delivery. Next. So so overall we have five constraints to overcome with a one on pickup must resist the delivery. Two, or not of the request must be resisted by the same vehicle. Three, time windows must be respected as it not. And four, vehicle capacities and availabilities must not be exceeded. Finally, the objective is to minimize total routing costs while serving on request. Next. So this is a three-part research objective.
Oh, okay. Thank you, Jennifer. And hi, Professor. Now I will tell you about the research objectives of this paper. This paper aim to investigate the multi-pickup and delivery problem with time windows in which a set of vehicles is used to collect and deliver a set of items, and they also define its request as several pickups of different items followed by a single delivery at the client location, and they also try to minimize the overall routing cost subject to both time window and precedent constraints. Next. So the problem they try to address here, and they need to identify four key constraints. First, they ensure flow conservation and that all nodes of a request belong to the same vehicle, and limit the number of vehicles used in the solution, guarantee schedule feasibility with respect to time windows, and force a request to be served by only one vehicle. Next. And I will talk about the methodology of this paper. And we have a mathematical formulation here. The multi-pickup and delivery problem with time windows can be formulated as a mathematical programming problem with the following decision variables. So we have three decision variables here. its K E G is 1 if at port E to G is traversed by the vehicle case, and the port 0 otherwise, and Y or K is 1 if request R is visited by vehicle K, 0 otherwise, and SE indicates the beginning of service at node E belong to the V, and the most important here, they have objective function to minimize the overall transportation cost from uh, node E to node G on each vehicle. And next, and in this paper, and in this paper, they have 10 constraints in total, and the objective is that they identify a vehicle only depart not E if it has been assigned the request containing E, and a vehicle only arrive at not E if it's been assigned the request that include E, and each vehicle can depart or assign to exactly one vehicle or depart from the depot not zero at most once. Next, and the surface at node E must must be between must be within its designated time window between the AE to BE, and ensures temporal feasibility if vehicle travel from port E to Z, and for each request, deliver nodes must be visited after all its pickup node E belong to P, and constraint 9 and 10 is a binary variables. And next, so besides the mathematical formulation, they also adapt the hybrid adaptive is so-called adaptive last neighborhood search heuristic with improvement operations. Uh, First, they try to generate studying solution by construction heuristics, apply removal and insertion operators, and improve promising solution with local search. Next, um, furthermore, along with the hybrid ALNS, this paper they have five algorithms. In the first algorithms, they it aims to find high quality solutions by removing, reinserting, and improving rules using adaptive operators and simulated annealing. Next, and in the second algorithms, they try to target location and exchange moves on the current solution to intensify the search and quickly police rules before they are accepted. Next, and you can see here the third algorithms to reinforce operators that contributed to good or accepted solutions and to balance operation versus exploitation throughout the search. And the four algorithms next. The four algorithm, its purpose is to gradually reduce the likelihood of accepting worse a solution over time while resetting the temperature to escape local optimal. And the final algorithm next. Its purpose is to generate a feasible studying tool quickly, so the ALNS framework had a valid baseline to improve upon. And next, the Miss Resy will tell us about the results and discussion.
Thank you, Jennifer and Dewey. Result and discussion. So first is experimental design. So for experimental design, they have three kind of experimental, which is have algorithm robustness included intent site 25, 50, 140 nodes, and the time window types have none, normal, and large. For request length, they have short for node and long egg node request. The three of the experimental, that's one is instant generation, that's the creative 120 test instant based on the classification MPDTW MPDPTW, and parameter. The second one is parameter variation. That's testing different node count and time windows type and request length. The last one is algorithm tuning. It's mean optimize parameter through primarily testing. So for a ALNS SEN, performance on small instance. What is the small instance? A small instance to medium instance is mean 25 until 100 nodes. So ALNS algorithm, they more improve efficiency for a computation time. You can see like 2 until 20 second for computation time for fast processing small instead from 25 until 100 knot. For minimum deviation, we got 0.27% from the best solution across test instance. And for maximum deviation, that is 1.5% from best solution across a test instance. So you can see that is a computation result algorithm perform. They have from instead from 25 knot until 400 knot. That's in the last is 400 knot is deviation is 0.75. The perform in impressive considering the combinatorial exploration that's typical with vehicle routing problem as the size increases. Then in the impact of the time windows, they have impact, three kind of impact. First is no time windows. This means the algorithm perform efficiently with complete schedule freedom. For the second one is normal time windows. It means the maintain high solution quality despite at constraints. The last is large time windows. They often produce better solution due to increased flexibility. So we want to compare with the exact methods SPLEX Limited and ALNS Advanced. For SPLS Limited, they have only solved 60 or 120 instead optimally. All solved instead are small than 100 nodes. Of all of them filed 400 node instead, and the memory limited with large problem. Uh, for ALNSF10, the solve all 120 tests instead, the solution equal or better than CPLX and the handle 400 nodes instead efficiently. Then the last is practical computation time. So this means the ALN is a more better method than CPLX limitation. So for optimality gaps, you can see the table result LS and CPLX. They have 25 knot until 400, and you can see that the large is 400. See, ALNS continue to meet CPLX solution, but optimal gaps grew even large, often exceed 60%. It's mean unable to solve. For the medium instead, they have 100 knots. ALNS again match with the CPLX solution, but optimality gaps. So the medium is instead is optimality gaps, and the last is small instead, but for that result, it means some optimal solution. So robustness and stability analysis, they have four kind of that. Is first is neighborhood searching. It means we need to identify promising solution regions, and the second one exchange operator is means web element to improve solution, solution stability into consistent result across multiple runs. And the last is relocate operators is meant to move element to better position. So for the key contribution from this paper, they have three kind of key contribution. One is new birth data set 120 tests instead for MPD MPDPTW research, and the second was specialist operator for the new removal and inserted technical for multi pickup constraint. The last is perform demonstration. It means heuristic outperforming exact method on large scale problem. The practical implementation, we divide the three kind of practical. First is algorithm implementation, integration. So the integration into the logistic management system, and for operational optimization to improve routing efficiency and resource utilization. And the last, of course, for business impact, for cost to reduce and enhance service quality. Now we're going to conclusion. The conclusion for this paper, that we got 4 point. The big point is first is novel problem. So from the MPDPTW expensive reach and the new problem in the field and pickup and delivery vehicle routing with imported the real world application. The second one, effective solution. So in the journal, they mentioned that hybrid ALNS heuristic with special operator efficient solve instead of various sites and characteristics. The third one, superior performance. That is mean our the output from this journal, that's exact method, especially for large instead and well maintaining high solution quality. The last is foundation for future work. This research stability of fund for future exploration, this problem class and variance. And conclusion, we get also the computation result, that we get the ILNS algorithm that robust, scalable, and efficient, solving instead up to 400 knots. And for high quality solution, we also get less than 1.5%. And the last is we got outperform CPLEX in practice. For this future research direction from this paper, need to improve the model, the flat need to heterogeneous, and I'll need to loading constraint, and maybe the order pick up need to must be visit in a giving order. Okay, this is all our presentation. Thank you very much, Professor. Bye bye.